You wake up every day and assume something very simple has happened. You think, I was asleep, now I'm awake. But that's not really what happened. Something far stranger took place, something so ordinary that we never question it, and yet so complex that science still struggles to fully explain it. Waking up is not a clean switch. It's not like flipping a light on in a dark room. It's more like a system trying to restart while parts of it are still offline, still loading, still confused. And the strange part is, you are inside that system while it's happening. For a brief moment, sometimes just a few seconds, sometimes longer, you are not fully yourself. To understand this, imagine your brain as a massive city. During the day, everything is coordinated. Signals move smoothly. Decisions happen quickly. Every system is synchronized from perception to memory to action. There's a sense of order that feels so natural you don't even notice it. But at night, the city changes. Some areas shut down almost completely. Others become active in unusual ways. Maintenance begins. Old information is sorted. Unnecessary details are removed, and important memories are reinforced. Activity doesn't stop, it just becomes different. Less structured, more internal, sometimes even chaotic. That's what sleep really is. Not silence, not emptiness, but a completely different mode of operation. Now here's the key idea. When you wake up, your brain does not instantly switch from this nighttime mode to the organized state you experience during the day. There is no sharp boundary. Instead, different parts of your brain wake up at different times. The systems that control basic survival, breathing, heart rate, simple movement come online first. They have to. Without them, nothing else matters. But the parts responsible for thinking clearly, making decisions, and understanding reality take longer. They don't snap into place immediately. So for a short period of time, you are conscious, but not fully assembled. Let's think about it in another way. Imagine a computer that crashes unexpectedly. Not everything shuts down properly. Some processes freeze halfway. Then the system tries to restart. One part boots up quickly, another lags behind, and some files are still incomplete. For a moment, the computer works, but strangely, it misinterprets inputs. It runs slowly. It might even show fragments of what was happening before it shut down. That's very close to what your brain is doing when you wake up. You might have felt this before without thinking much about it. You open your eyes, but your thoughts feel heavy. The room looks familiar, but there's a slight delay in recognizing it. Your mind is slow, almost like it's moving through fog. For a few seconds, nothing feels fully stable. This isn't just tiredness. It's not laziness. It's a partially active system trying to rebuild itself in real time. And in that brief window, something unusual happens. The world you experience is not fully reliable yet. You are not just waking up. You are being reconstructed. Your brain never truly sleeps in the way you imagine. It doesn't switch off like a machine that loses power. Instead, it changes its way of working. The same physical structure is there. The same billions of neurons are active. But the pattern of activity shifts into something completely different from what you experience when you're awake. Think of it like a city that never goes dark. During the day, everything feels organized. Traffic flows in predictable patterns. People communicate clearly. Systems are synchronized, and there is a sense that everything is working together toward a common structure. This is what your waking brain feels like: ordered, logical, stable. But at night, that same city transforms. Some areas shut down almost completely. Offices close, streets empty, and many processes slowed to a minimum. At the same time, other areas become more active in ways you don't usually notice. Maintenance crews come out, repairs begin, systems are tested, reorganized, sometimes even rebuilt. The activity doesn't stop. It just becomes less visible and less structured. Your brain behaves in a very similar way. When you fall asleep, it cycles through different stages, each with its own pattern of activity. In deep sleep, large regions of the brain begin to fire in slow, synchronized waves. It's almost like the system is lowering its activity to a steady rhythm, conserving energy and resetting basic functions. In this state, your connection to the outside world is minimal. Sounds light and touch barely register. Then comes another phase, REM sleep, where everything changes again. Here, the brain becomes highly active, almost similar to when you are awake. but the activity is turned inward. Instead of processing the outside world, it starts generating its own internal reality. This is where dreams come from. The brain constructs entire scenes, emotions, and experiences without any external input guiding them. And the strange part is, while this is happening, your body is effectively disconnected. Muscles are temporarily paralyzed so that you don't physically act out what your mind is experiencing. You are living in a world created entirely inside your own brain. Now consider what that means. For several hours every night, your brain is operating in a mode where reality is internally generated, not externally verified. The rules are different. Logic is flexible. Time behaves strangely. Identity can shift without warning, and yet, while you are inside that experience, it feels completely real. You don't question it while it's happening. You accept it. That tells us something important. Your brain does not need the outside world to create a convincing sense of reality. It can build one on its own. Now think about what happens when you wake up. You are not stepping out of nothingness into reality. You are transitioning from one kind of reality to another, from an internally generated world to one that is constrained by sensory input. But that transition is not instant, and it's not clean. Some parts of the brain are still operating under the rules of the dream world. Others are beginning to process the external environment. For a short period, these two modes overlap. That overlap is where things become unstable. You might still carry fragments of dreams into waking life, emotions that don't match your situation, images that linger for a moment, thoughts that don't fully make sense. It's as if the brain hasn't fully decided which version of reality it should commit to yet. And during this time, your experience of the world is not fully grounded. You are not just moving from sleep to wakefulness. You are moving between two different systems of reality, one created entirely by your mind, and one shaped by the outside world. And for a brief moment, you exist somewhere in between. When you wake up, your brain does not instantly switch from sleep to full wakefulness. Different regions awaken at different speeds, and this uneven transition creates a state that is neither fully asleep nor fully awake. It is a messy, overlapping process, and for those first few seconds or minutes, you are operating in a partial mode of consciousness. The systems that control basic life functions like breathing and heart rate come online almost immediately. These are the fundamental processes your body cannot afford to delay. Movement also returns quickly, which is why you can sit up or reach for something soon after opening your eyes. But the higher order regions, particularly the prefrontal cortex, the area responsible for reasoning, decision-making, and self-awareness, wake up more slowly. Your mind is functioning, but it is not fully coordinated. Attention, focus, and judgment lag behind your physical actions. During this transition, even your perception of time can be distorted. Seconds may feel stretched, thoughts may move sluggishly, and the environment around you can appear slightly unreal. Your mind is essentially rebooting, reloading its internal operating system. It is reestablishing the connections between memory, sensory input, and reasoning that form what you think of as normal, conscious experience. For a brief period, you are conscious without having full access to the capabilities that define your waking self. This phenomenon explains why you sometimes feel disoriented upon waking. You may glance at the clock and misread the time, or you may briefly forget where you are or why you are in a particular room. These moments are not signs of weakness or absent-mindedness. They are the natural result of different brain networks awakening at different rates. Your subjective sense of self is gradually reconstructed from fragmented systems, each coming online at its own pace. Sleep inertia, the technical term for this groggy, semi-conscious state, can last anywhere from a few seconds to several minutes, depending on the stage of sleep you were in prior to waking. If you wake from deep, slow-wave sleep, your brain is far from prepared for the sensory input and reasoning required during waking. If you wake from lighter sleep or REM sleep, the transition may be quicker, but there can still be a period of partial awareness. During this time, the brain is recalibrating its perception of reality, restoring memory connections, and integrating internal thought with the external world. The process is similar to a computer restarting. If a complex program crashes, the system may begin to load its components in stages. Some subsystems become active immediately, while others lag or experience temporary errors. During this partial startup, the system is functional but not fully stable. Input may be misinterpreted, and responses may be slow or inaccurate. Your waking mind operates in a comparable way, processing information incompletely and verifying reality with reduced efficiency. During this early stage, cognitive performance is impaired. Your ability to plan, make decisions, and respond appropriately is diminished, and your awareness of your surroundings is not fully accurate. This is not a flaw, it is a necessary compromise of a system that has to balance repair. Consolidation and readiness over the course of a 24-hour cycle. The brain prioritizes essential functions first, and only then restores full cognitive capacity. For a short window, you are vulnerable, not in the sense of danger, but in the sense that your internal representation of the world and of yourself is still incomplete. This transition demonstrates something profound about consciousness. It is not a single, continuous state. It is a dynamic process that can fragment and rebuild. Waking up is not merely the return of awareness. It is a complex orchestration in which different layers of your mind reconnect, restore functionality, and gradually bring your subjective experience into alignment with the external world. It reveals that the self we take for granted is not a static entity, but a construction that must be carefully reassembled each morning. The grogginess you feel when you first wake up is called sleep inertia, but that term doesn't fully capture what is happening. It is not simply feeling tired or sluggish. Sleep inertia is a physiological and neurological state in which your brain is partially active but not yet fully synchronized. Your body can move. Your eyes can open. You can even speak. But your higher order cognitive functions are still offline or operating at reduced capacity. You are conscious, but your mind is not fully online. The parts of your brain that govern survival, the brainstem and other basic systems, come awake first. These areas control breathing, heart rate, and simple motor responses, which is why you can sit up, reach for something, or even walk around without thinking. The prefrontal cortex, which handles reasoning, decision-making, attention, and self-reflection, takes longer to catch up. This imbalance between regions means that for a short period, you are awake without having full control over your thinking or perception. Your ability to analyze situations, solve problems, or respond to unexpected stimuli is diminished. Sleep inertia can last anywhere from a few seconds to more than half an hour, depending on factors like how long you slept, what stage of sleep you were in before waking, and your overall brain chemistry. If you wake from deep, slow wave sleep, your brain is far from prepared to process the external environment, and the grogginess is stronger. If you wake from a lighter stage or REM sleep, the transition is faster, but there is still a brief period in which your brain is not fully integrated with reality. During this window, you are functional, but you are not fully yourself. During sleep inertia, your subjective perception of time, space, and identity can be distorted. A few seconds can feel like minutes, and simple decisions may take longer than usual. Your brain is recalibrating, reconnecting sensory input with memory and thought, and gradually restoring what you recognize as coherent awareness. It is as though you are rebooting a system that has been offline for hours, and some components take longer to load than others. This is why early morning mistakes happen more easily. Misreading the time, forgetting where you are, or losing track of a simple task is not a matter of carelessness. It is a natural consequence of your brain's staggered recovery. Your systems prioritize survival and sensory awareness first, higher reasoning second, and full integration of memory and self-awareness last. For a few moments, the internal world of your mind is not fully aligned with the external world, leaving a temporary gap in perception and judgment. Think of it like a computer restarting after a crash. Core systems load first, the operating system, basic drivers, but other applications take longer. During this process, input can be misread, commands executed incorrectly, and outputs may be delayed. Your waking mind operates similarly, processing reality incompletely. Cognitive and perceptual functions are partially online, creating a fragile, semi-formed state of consciousness. Even in this partial state, your brain is still performing essential functions. It is sorting memories, checking for danger, and gradually reestablishing full awareness. The grogginess is a byproduct of a system that is not yet fully synchronized, a brief period when your internal representation of reality is incomplete. The brain prioritizes basic survival and recalibration before restoring higher-order cognitive functions. Sleep inertia demonstrates that consciousness is not a single unified state. It is dynamic, layered, and dependent on the proper synchronization of multiple systems. Waking is not simply the return of awareness. It is a carefully orchestrated reconstruction of the mind in which attention, memory, perception, and self-awareness gradually come back online. During this brief period, your mind is awake, but it is still rebooting, revealing that even in ordinary moments, consciousness is a process rather than a static entity, even after your eyes open and your body begins to move. Part of your brain can still be operating in dream mode. This means that elements of the world you are experiencing are still internally generated, not fully constrained by sensory input from your environment. Your mind is essentially in a hybrid state where fragments of dreams and thoughts intermingle with real-world perception. This is why waking up can feel strange, disorienting, or surreal. For a few moments, your mind is not fully tuned to reality, and the world around you can feel subtly distorted. During sleep, particularly in REM stages, your brain is highly active. It generates experiences, emotions, and narratives entirely internally. When you wake, the process of disengaging from these internally generated scenarios does not happen instantaneously. Some dream activity can bleed over into your waking state, affecting your thoughts, emotions, and perceptions. For example, you might briefly feel a lingering emotion from a dream, or an image or sound from the dream may seem to persist for a moment in the real world. These fragments are usually fleeting, but they are a clear demonstration that your brain is transitioning between two fundamentally different modes of operation. This transitional state highlights the brain's remarkable ability to construct reality. While dreaming, the brain creates a complete internal world, often vivid and emotionally charged, with its own sense of time, space, and narrative logic. This internally generated reality is convincing enough that when you are dreaming, it feels entirely real. Your brain does not need sensory input from the outside world to create coherent experiences. This demonstrates that much of what we perceive as reality is actively constructed, even when we are awake, and even more so when we are asleep. When you wake up, your mind has to reorient itself, suppressing dream activity and recalibrating sensory input. But the process is not uniform across the brain. The areas responsible for visual processing, memory, and attention may activate at different rates, while emotional or associative regions may remain partially engaged in dream-like patterns. This is why you might experience an emotional residue from a dream or a fleeting hallucination like perception. These experiences are natural and indicate that the boundaries between dreaming and waking are not fixed but fluid. For a short period, your mind is integrating two layers of reality: the external environment and the internally generated scenarios from sleep. These layers can overlap, causing small inconsistencies in perception and thought. You may misinterpret visual cues, feel a sudden sense of familiarity or fear, or have a fleeting thought that seems disconnected from your current situation. These moments reveal the brain's ongoing work in constructing coherent experience and demonstrate how delicate the synchronization of different neural systems can be. The fact that dreams can influence waking perception, even briefly, shows that consciousness is not a single, continuous stream. It is composed of multiple interacting systems, each contributing to your experience of reality. During waking, these systems must coordinate rapidly, suppressing internal simulations while amplifying sensory input and rational evaluation. The early moments of wakefulness, therefore, provide a rare glimpse into the mechanics of consciousness, showing how fragile and adaptive the process is. Even though this transition is brief, it is profoundly revealing. It demonstrates that reality, as you perceive it upon waking, is a construction of your mind, subject to temporary distortions and overlays from dream activity. Your waking self is not a simple observer, but an active participant in assembling the world you experience. This period of partial dream overlap reminds us that consciousness is a dynamic, layered process, and that even the ordinary act of waking up is a remarkable demonstration of the brain's ability to create coherent experience from multiple, sometimes conflicting sources. Sometimes as you are waking up, the brain's dream-generating systems are still partially active, while the reality monitoring systems are not fully online. This overlap can create brief hallucination-like experiences called hypnopompic hallucinations. You may see a shadow in your room, hear a faint voice, or feel the presence of something that isn't there. These experiences can be startling, but they are not evidence of anything supernatural. They are a natural result of the brain transitioning between two fundamentally different modes of operation. During sleep, particularly REM sleep, the brain is creating vivid internal experiences that feel entirely real. Sensory processing, memory, and emotion are all engaged in a way that produces a convincing internal reality. When you wake, the sensory systems responsible for interpreting the outside world are coming online, but they do so at a different pace than the systems that generate internal experiences. This mismatch creates a temporary state in which dream-like imagery or sounds are treated by your mind as potentially real. The brain's reality check mechanisms are delayed, allowing these internal signals to slip into waking consciousness for a brief moment. This shows that perception is not simply a passive reflection of the external world. It is an active process in which the brain constructs a coherent experience by integrating multiple sources of input. During normal wakefulness, this integration is highly reliable, which is why you trust your senses implicitly. But during the transition from sleep to wakefulness, the integration is incomplete and your perception can be skewed. The brief hallucinations that sometimes occur upon waking are evidence that the brain is constantly negotiating between internal and external sources of information, even if you are usually unaware of it. The fact that the brain can generate experiences that feel real without any external input demonstrates something profound about consciousness. Your mind can create entire scenarios complete with visual, auditory, and emotional content without any real-world stimuli. In dreams, this ability is fully expressed. When remnants of these internally generated experiences intrude into waking life, it highlights how constructed your sense of reality truly is. The brain is not simply receiving information from the world. It is actively assembling it, interpreting it, and sometimes misaligning it during transitions. Hypnopompic hallucinations are more common than people realize. They often occur when waking from deep sleep, or when the brain is abruptly transitioned into wakefulness. People might see figures, lights, or shapes that vanish moments later, or they might hear sounds that fade as attention and reasoning return. The experiences can feel vivid, but they are fleeting because the prefrontal cortex and sensory systems quickly synchronize, restoring a coherent reality-based perception. These brief hallucinations reveal the fragility and adaptability of consciousness. They show that even the most ordinary experience, waking up, relies on a delicate balance between multiple neural systems. Your brain must suppress internally generated signals from sleep while rapidly engaging external sensory inputs, reconstructing memory, and restoring attention and reasoning. For a few seconds, the balance is imperfect, creating experiences that are simultaneously real and unreal, generated and perceived. Understanding these phenomena emphasizes that consciousness is not a single unified stream but a dynamic process. It is an active negotiation between different systems, continuously constructing reality. Waking up with all its fleeting distortions is a striking example of how perception, memory, and reasoning must synchronize to produce the stable experience we take for granted. These moments remind us that our sense of reality is always a construction of the brain, temporarily revealed in its imperfect state during the transition from sleep to wakefulness. When you first wake up, there are moments in which your sense of self feels incomplete. For a few seconds, your identity is not fully assembled. You know you exist, but the parts of the brain that create a coherent understanding of who you are, where you are, and what you are doing are still booting up. Your memory, spatial awareness, and self-recognition are gradually restored, which is why you might sometimes stare at your surroundings and briefly wonder, Where am I? Or what day is it? This is not confusion in the usual sense. It is a natural consequence of your brain's staggered awakening. The prefrontal cortex responsible for reasoning, planning, and conscious thought comes online more slowly than the brainstem and motor systems, which manage basic survival functions. Your body may be moving, your heart is beating, your eyes are open, and yet the higher, order cognitive functions that define yourself are still reconnecting. During this time, fragments of memories and identity must be reintegrated. Your brain is effectively asking, who am I right now? And where should I place myself in the world? For a brief window, that answer is incomplete, leaving you in a state of partial awareness. This temporary vulnerability is not just an abstract phenomenon, it has tangible effects. Your judgment is weaker, your decisions may be slower, and your perception of reality can be slightly distorted. The internal sense of self that we rely on for everyday reasoning is still under construction. And until it is fully operational, you are operating in a state that is neither fully dream nor fully awake. You are in a liminal space, suspended between two modes of being, where the continuity of your consciousness is momentarily disrupted. Your identity is not a static entity that exists independently of brain activity. Instead, it is a dynamic construction, continually rebuilt from neural processes, memories, and sensory input. Each morning, as the brain transitions from sleep to wakefulness, it reassembles these components, gradually restoring a coherent self. The fleeting moments when this process is incomplete provide a rare glimpse into the mechanics of consciousness, showing that the you experience is not a fixed essence but an emergent property of synchronized brain activity. Memory plays a crucial role in this reconstruction. The hippocampus, which is involved in forming and retrieving memories, is still stabilizing connections during the transition from sleep to wakefulness. Some memories may momentarily feel inaccessible, while fragments of dreams or recent experiences may intrude. This combination of missing and intrusive information contributes to the sense of disorientation and the incomplete feeling of self that often accompanies the first moments of wakefulness. Spatial awareness is similarly affected. Your brain must reestablish a sense of the environment and your place within it. Visual, auditory, and tactile information are integrated with memory to create a stable perception of the world. Until this integration is complete, objects may appear slightly unreal, distances may feel distorted, and familiar places may momentarily seem unfamiliar. Your sense of orientation and position in space is rebuilt alongside your sense of identity. Emotion also plays a role in reconstructing self-awareness. The limbic system, which processes emotions and drives, may remain partially influenced by dream content or by the residual neural patterns of sleep. Emotional responses can feel heightened or disconnected from reality for a few moments, further contributing to the sense of an incomplete self. The reconstruction of identity each morning demonstrates that consciousness is not continuous. The you that wakes up is not the same as the you that fell asleep. Identity, memory, spatial awareness, and emotion are all temporarily disassembled and then reintegrated by the brain. For a short period, you exist in a transitional state where your sense of self is provisional, revealing that the continuity of personal identity is an active process rather than an automatic or fixed condition. Science has made remarkable progress in understanding the mechanics of sleep and wakefulness, yet there remain profound mysteries. We know a great deal about the electrical patterns in the brain during different stages of sleep. Using EEGs, researchers can observe slow waves in deep sleep and the rapid, desynchronized activity of REM sleep. We know about the chemical messengers, such as serotonin, dopamine, and acetylcholine, which help regulate the transitions between sleep stages and wakefulness. We understand that specific brain regions like the prefrontal cortex, hippocampus, and thalamus play crucial roles in attention, memory consolidation, and the perception of reality. We also understand phenomena like sleep inertia, hypnopompic hallucinations, and the staggered awakening of brain systems. These concepts provide a framework for understanding why waking can feel disorienting, or why dream remnants sometimes spill into our perception of reality. We can even predict with reasonable accuracy How waking from deep sleep versus light sleep will affect cognitive performance in the minutes following awakening. Yet, despite all this knowledge, the most fundamental question remains unanswered: how does consciousness itself emerge from these processes? We can measure brain activity, map neural pathways, and observe chemical changes, but we cannot explain the subjective experience of being awake. We do not know why a specific pattern of neurons firing produces the feeling of I exist, or why the integration of sensory input and memory reconstruction results in a coherent sense of reality. There is a gap between what can be observed scientifically and what is experienced internally, a gap that persists even in modern neuroscience. Humans struggle to explain this because consciousness is not directly measurable. Unlike a heartbeat or a chemical concentration, subjective experience cannot be quantified or recorded in any straightforward way. Scientists can infer it from behavior or brain activity, but the qualitative aspect, the actual feeling of being alive and aware, is inaccessible. This is why waking up, something so routine, can reveal the limitations of our understanding. It shows us that even ordinary events involve processes that are intricate, delicate, and in some ways, still mysterious. Another challenge lies in the dynamic and distributed nature of brain activity. Consciousness does not reside in a single region of the brain. It emerges from the coordinated activity of multiple networks, each responsible for different components of experience perception, memory, attention, emotion, and reasoning. During the transition from sleep to wakefulness, these networks awaken at different speeds and interact in complex ways. This staggered activation is why waking is not instantaneous and why the mind can experience fragments of dreams or altered perceptions. The complexity of this network makes it difficult to pinpoint a single mechanism for consciousness. Even with advanced neuroimaging and computational models, we can only approximate how these processes work together. We understand patterns and correlations, but we do not have a causal, mechanistic explanation for subjective awareness. Waking up offers a glimpse into these dynamics because it is a controlled, observable shift from one mode of consciousness to another. It highlights the brain's remarkable capacity to reconstruct reality, reintegrate memory, and restore identity, all while exposing the fragility and contingency of consciousness itself. This shows that science can explain mechanisms and patterns, yet the essence of experience, the what it feels like to be conscious, remains elusive. Even in 2026, waking up is a reminder that human understanding, though advanced, is still incomplete. It invites curiosity, humility, and continued investigation into the relationship between brain, mind, and reality. The moments immediately after waking are when you are most vulnerable, not because of physical weakness, but because your brain is in an unstable, transitional state. Your cognitive functions are partially offline, your perception is not fully reliable, and your ability to respond effectively to the world is temporarily diminished. During this brief period, the mind has not yet fully synchronized its networks, leaving gaps in reasoning, attention, and situational awareness. Vulnerability here is about fragility in the construction of reality, not physical exposure. Your perception of the world is incomplete. Sensory input is still being integrated with memory and attention, so the stability and coherence of your experience are fragile. Visual cues may feel slightly off, spatial relationships may be misjudged, and familiar objects may momentarily seem strange. These distortions are fleeting, but they highlight the fact that your brain is constantly building reality rather than simply observing it. What you see and understand in the world is always a reconstruction, a model that the brain creates based on incomplete and continuously changing information. Decision-making is also impaired. The prefrontal cortex, responsible for reasoning and judgment, is one of the last areas to fully wake up. You may be able to move, speak, and respond to basic stimuli, but your ability to plan, evaluate, and anticipate consequences is reduced. Simple choices may feel harder, and complex decisions are more error-prone. This explains why groggy mornings can produce unusual mistakes, spilling coffee, misplacing objects, or misjudging simple tasks. The mind is temporarily operating in a state of partial competence. Emotion plays a role in this vulnerability as well. The limbic system, which processes emotion, is often more active or less regulated during the transition from sleep to wakefulness. Residual feelings from dreams or incomplete neural inhibition can amplify fear, anxiety, or excitement. These emotional fluctuations further destabilize the mind's perception of reality, making you more sensitive to stimuli or more likely to misinterpret neutral events. Memory integration is incomplete during this phase. The hippocampus, responsible for retrieving and consolidating memory, is still coming online. You may experience lapses in recall or feel disconnected from recent events. Fragments of dreams can intrude into consciousness, blending with reality in ways that momentarily confuse perception. This blending is a demonstration of the brain's active process of creating continuity between past experiences, current sensory input, and the construction of self. Vulnerability during this period reveals the fragility of the conscious mind. Even ordinary tasks become precarious when the brain is partially active. Your internal sense of self is provisional. Your perception of the environment is incomplete, and your reasoning is slow. These moments are not dangerous in the usual sense, but they highlight how dependent our conscious experience is on the precise coordination of complex neural systems. This transitional state reminds us that consciousness is not a fixed entity. It is dynamic, layered, and continuously reconstructed. The stability we take for granted in our perception and reasoning is actually maintained by ongoing coordination of multiple brain regions. When that coordination is temporarily disrupted, even for a few seconds, the mind becomes fragile, revealing the remarkable complexity behind ordinary awareness. Vulnerability, then, is a natural feature of waking consciousness. It is not a weakness, but a necessary part of a process in which the brain rebuilds reality, restores memory, reactivates perception, and reconstructs identity. Understanding this fragility allows us to appreciate how extraordinary the seamless functioning of consciousness truly is, and how dependent we are on the precise orchestration of neural systems every moment of the day.